All right, so
I'm gonna do my work on the whiteboard.
quiz, and even if this wasn't your quiz, you might want to take it down just for practice. All right, so here we go. Cosine cotangent over 1 minus sine minus 1 equals cosecant. All right, this was on quiz number 3. All right, so we look at this, and what occurs to you maybe would be a good idea? Change the cotangent into what? Cosine over sine. So cosine over sine over 1 minus sine minus 1. Now, this, when I multiply this together, would be cosine squared over sine over 1 minus sine. Would you agree with that? This is cosine squared over sine. Now I'm going to multiply everything by sine to clear out that fraction right there. So that's going to give me what? These are going to cancel. So on top I'm going to have cosine squared. And on the bottom I'm going to have sine times 1 minus sine. Now this is where you want to be a little bit astute.
Cosine squared is sine.
Cosine squared isn't sine squared, but cosine squared is 1 minus sine squared. So we can change that into 1 minus sine squared. And what do we know about 1 minus sine squared? Every time something like that pops up, we know we can factor it into the difference of squares. So 1 minus sine, 1 plus sine, over sine, 1 minus sine, minus 1. So let's see. This is going to cancel. Do you agree with that?
Yep.
So now we have, I'm going to come over here because I'm out of room. So now we have 1 plus sine over sine minus 1. Now you can do one of two things. You can get a common denominator if you want, or you can split this up if you want. If you split it, it would be 1 over sine plus sine over sine minus 1. Now what's sine over sine? 1 minus 1, that goes away, and all we have left is 1 over sine, which is cosecant. Yep. If you got a common denominator, same thing's going to happen. You're going to have 1 plus sine minus sine, so those are going to cancel, and all you're going to have left is your 1 over sine, which is cosecant. Okay? Looks so easy when I do it, doesn't it? All right, let's try this one now. This was another quiz question.
God bless you.
All right, so what's your thought on that one?
Cosine and sine.
Yeah, so, well, actually, that's a great thought. You might also notice that you got a cotangent squared, and there's something about cotangent squared, I always have to write it down. 1 plus cotangent squared is cosecant squared. So you could take that cotangent squared and replace it with what? Cosecant squared minus 1. And what kind of would be a good thing about that? it factors into the difference of squares and it'll cancel your denominator. Now, the meat and potatoes way of doing the problem, you know, I gotta do something, what do? Would be to change into sines and cosines. If you are really thinking, you might notice, oh, I can change that into cosecant squared minus 1 and then cancel. If you did that, you have cosecant squared minus 1, and then you can factor that into cosecant plus 1, cosecant minus 1. These are going to cancel, so you are left with cosecant minus 1, which is 1 over sine minus 1, which is 1 over sine minus sine over sine, which is 1 minus sine over sine. Is that okay with everybody? But again, you could change this into sines and cosines. If you do that, those of you that did it, did you have a cosine squared in your problem? Yes, you did. And in order to end up with this, at some point you had to change that cosine squared into 1 minus sine squared. Right?
So your minus 1, you just put minus sine over sine.
To get a common denominator. Right? We need a common denominator so we can add those two fractions together. Now they have the same denominator. Right? Could do it without the common denominator. Alright, and then the last one. Oh wait, that's the same one. Okay, we have tangent squared plus 1 times cosine squared minus 1. Oops, we're the same variable. Equals negative tangent squared. Alright, now this problem was actually probably the easiest one, but some of you took a very long route and got lost along the way when you really didn't need to. This is really, could be very simple. What's 1 plus tangent squared? Secant squared. Now, be careful here. That is negative sine squared. It is the opposite of sine squared. Remember, your identity is sine squared plus cosine squared is 1. If you rearrange it so that it's cosine squared minus 1, if you bring the 1 over here, so you have cosine squared minus 1, then you got to take this guy over here and he will be a negative sine squared. What's secant squared? 1 over cosine squared times negative sine squared. What does that leave you with? Negative sine squared over cosine squared, which is negative tangent squared. Okay? Now, let's just get this straight before we take this test on Wednesday. I know this is where you're supposed to be going. I know whatever's over here is what you're going to end up with. You're not fooling me if you put in a bunch of gobbledygook and all of a sudden at the bottom say negative tangent squared. Alright, that makes me mad because you're trying to fake me out. I love Emily Schomer because I'm grading her paper. She's got all this junk going on and finally she says, I don't know what to do or something like that. She didn't try to fake me out and write negative tangent squared. She just said, I'm lost. I don't know what to do.
I tried.
That's what you should do. I tried. Now, this trying to fake me out is ridiculous. I'm going to go through every step, and I want to be able to follow what you're doing. And if you're not getting where you're supposed to be, you're going to lose points no matter what you put at the bottom. And if I'm mad, you get fewer points, okay? So don't make me mad. Just be honest. Do the best you can. All right. Is there anything else on the quizzes? any of the other things that we need to look at or talk about? Okay, secant and cosine have what relationship to each other? They are reciprocals. What happens when you multiply reciprocals? That's true. It's true. All right, anything else? Francis, what's on that iPad? Okay, they are what they are. Let's work on making them better, okay? Okay? All right, let's finish our worksheet. Are we ready now for part 6? Review sheet 5154, is that what we're on? I don't think we finished it. Did we? Oh, okay, so this class isn't the class on the review sheet? All right, but we finished that, so we're good. All right, did we also in this class do the quick review that is the last page in the packet? We did do that too? Yeah. All right, then here's what I want to do. I want to go back to the review sheet, which is the next to last page in the packet. And I want to go through the problems that I can read on this, because there are a couple of tricky things that I want you to be aware of on this review sheet. So this is review sheet 51 to 54, and I am starting with problem number 6. Okay, I'm starting with problem number 6 on review sheet 5154, which is the next to last page in your packet. This is an assignment also. I mean, you're to do this sheet, and we ought to be able to get through these last few, but there are 2 tricky ones that I need to talk about. The first one is not. 6A is not tricky. I'm going to change the pi over 2 into 90, and hopefully you know exactly what you're supposed to do with this. Next to last page, it's called review sheet. I'm on problem 6A. Okay? What do you do? Yep, so hate me up. You know what? Cosine
Cosine x, cosine 90, minus sine x, sine 90.
You are absolutely correct. That is your cosine of a sum formula. Cosine, cosine, minus sine, sine. Good. Now, we are going to plug in 4 things. Unfortunately, we don't know anything about x, or fortunately, whichever way you want to think about it. So that's going to stay cosine x, and that's going to stay sine x. There's not a darn thing you can do with that. But what about the 90s? Well, we know the 90s are up here, right? So cosine is x over r, so that will be 0. And sine is y over r, so that will be 1. So our answer is exactly what we'd hoped, negative sine x. Everybody good? Now, number 2, or B, this one is a little bit tricky. 3 pi over 2, 270. Now, your gut feeling is exactly right. You look at this and say, okay, it's the tangent of a difference. And that formula says tangent of the first minus tangent of the second. over 1 plus tangent of the first, tangent of the second. This is exactly what you should be doing. But we're going to run into a problem. Here's 270, right? That's 0, negative 1. I can't plug anything in for the tangent of theta, but the tangent of 270, this is our issue. What's the tangent of 270? It's undefined, because tangent is y over x, and y over x would be undefined, which means you can't plug anything in here. This doesn't exist. Oh man, that means that strategy, which is what we would think to do, simply won't work. It won't work because the tangent of 270 is undefined. So, who's got a different plan? Plan A is not going to work. Maria?
Do you put a negative outside of the theta?
Okay, now, she's thinking of reworking what's in here, and that would be okay, but you're still going to have the 270. And it's the 270 that's causing me problems because the tangent is undefined there.
Break down the 270.
Into
60 to 10.
270 would definitely break down into 60 and 210. You're exactly right. Here's my issue. Then I'm going to have 3 things in here because I can't get rid of the theta, so I'm still going to have my theta, and then I'm going to have my 60 and my 210. So when I do my formula, I can only do 2 at a time, U and V. So this would be like that formula twice. I'd have to go through and do it with maybe the theta and the 210, and then I'd have to get whatever answer I got there and go through and do it with the other angle, the 60. I've never done that. I'm not sure how it all comes out. It seems like it should come out. There's a much easier strategy though. What's the problem? The problem is the tangent of 270 is undefined.
So work the other side.
Well, a really smart person could do that. I don't know if I would be able to do that or not. How about this? What if we thought of tangent as sine over cosine? Now, isn't that what tangent is? And why is this not a problem for me? Because sine and cosine are never undefined. Remember what they look like when you graph them? They're never undefined. So if I have an issue with something being undefined, my best bet is get rid of the issue by changing it into sines and cosines. Now, this may look bad, but it's not going to be bad. What's the formula for sine theta minus 270? Sine theta cosine 270 minus cosine theta sine 270. Now you're saying, oh my gosh, Miss Ford, wait a minute. 270's right here, right? Am I going to be able to plug some numbers in there pretty easily? All right, and then in the denominator, I have cosine theta, cosine 270, plus sine theta, sine 270. All right, let's start plugging numbers in. What's the cosine down here? X over R. So the cosine will be 0. So the cosine is 0, which means what about this whole term? It's gone, right? Because it's just 0. What about this whole term? It's gone because it's 0. I'm not canceling those. You can't cancel those. They just both happen to turn into 0, right? Okay, what about the sine of 270? Negative 1. So I'm going to put a negative 1 in here. So my top is positive cosine, because it's minus a negative 1 cosine. Then put a negative 1 down here. and that would be minus sine. What is cosine over negative sine? Negative cotangent. All of the functions are undefined at places except sine and cosine. So if you run into an undefined, just change the problem into sines and cosines, and then you don't have an issue. Okay? All right, I can't read that last one. Can anybody? Mine's cut off.
Sin x plus y.
Is that what it is? Sine x plus y?
Plus sin x minus y equals 2 sin x.
Is it plus sine x minus y?
Yeah.
Now, you realize if we can't read it, what is it? 2 sine.
X cosine y.
All right. If you're reading it wrong, we're not going to get it to work out, right? All right, not going to spend a ton of time on it if we can't read it. But let's see if you guessed right. Let's see if you got it right. Let's work it out. So here we go. Formula for sine x plus y. Sine x cosine y. Plus, that's this plus right here. Here we go with this. That'll be sine x cosine y minus cosine x sine y. Alright, anything good happen?
The cosine x sine y is canceled.
Ooh, we got some canceling, that's good. Are the other two matches?
Yep.
Yep, and they do indeed, so you read it right. They add together to give you that good work. All right, part 7. Simplify, okay? Recognize the formula. Sine cosine minus cosine sine. That's the sine of
15 minus 15.
angle minus angle.
Yeah.
And the angles are 17 and 13, so this is the sine of 4. All right, how about the next one? Cosine squared minus sine squared.
1.
No, not 1. What would be 1? Cosine squared plus sine squared is 1. Okay? Ooh, gotta remember that. Cosine squared plus sine squared is 1. This is minus. What's cosine squared minus sine squared? Look on the back of your sheet. It's the cosine of the double angle, and the angle is 19. So this is the formula for the cosine of 38. Everybody okay with that? All right, let's see. Well, it's a sine formula. It's the sine of the half angle, and the angle is 12, so it's the sine of 6. That's exactly right. 2 sine cosine. 2 sine cosine. That is the formula for the sine of the double angle. And the angle is 83, so that's the sine of 166. Remember, you got to figure these out by yourselves. Are you getting it? Paying attention here? All right, what's next? Tan plus tan over 1 minus tan tan. That's the tangent of angle plus angle. And the angles are 12 and 5, so that's the tangent of 17. And now I got my super tricky problem, which I labeled super tricky. What's tricky about it? It's flipped. The actual identity is cosine cosine minus sine. Now, if it were cosine minus sine, that is a formula for what? Cosine of angle plus angle. But I got this turned around. So what I have is really the negative of this. Would you agree? So I have written down the negative of this. Well, this is the cosine of x plus y, which would be the cosine of 15 plus 11, the cosine of 26, but I have the opposite of it. I have the turned around version. So it's the opposite of the cosine of 26, or negative cosine 26. Now, I need you to pay attention to something though. What if it had been sine x sine y plus cosine x cosine y? Is that the opposite of anything? No, because addition is commutative. This is the same as cosine plus sine. Just because it's written backwards doesn't mean it's the opposite. Do you see what I'm saying? So pay attention. I had a kid take this problem, 2 cosine sine, and say it was the opposite of sine 2x. No, it's not. These are flipped, but isn't this exactly the same as 2 sine cosine? There's no opposite going on there. All right, so be careful. Before you say it's the opposite, make sure it really is the opposite. All right, and then the last problem, which is a solve, which means you aren't done until you say something like x equals 30 degrees. That's when you're done. When you are solving, you're going to say something like x equals 30 degrees. Now, I have no idea what the answer to this question is, but it's an angle or more, one or more angles. All right, so cosine 2x plus cosine x equals 0. It tells me to do it in degrees, and on the test I'll be more careful, and your directions will say something like this or like this. Okay, because I want you to go once around. I don't want all the coterminal angles and all that. That's a hassle. All right, so who's got an idea how to start this problem? Well, factoring is a wonderful idea. It's something we want to do in almost every one of these problems, but it's not possible at this point because this is a cosine 2x and this is a cosine regular x. They aren't like terms. There's nothing to factor at this point. Emily? Yeah, into something. Let's change the cosine 2x. We got to get rid of the 2x. Or make this a 2x, which no one would want to do that. You want these to match. So what's cosine 2x? Well, that's one of them that has more than one version. The quickest, most efficient version to choose in this problem would be 2 cosine squared minus 1. Because the problem already has a cosine in it. And remember, you were talking about factoring. And in order to factor, we have to have like terms. So it makes sense that since we already have a cosine, that we would get other cosines if we have a choice, and we do. So I'm going to put this in a little bit different order. And then hopefully you recognize that you have a little quadratic equation here. And it will factor. You cannot take a cosine out because you have that 1 on the end. but you can split it up into two parentheses. If the cosines bother you, think of it like this: 2x squared plus x minus 1, that's what you've got. You've got two things squared plus the thing minus 1. So how would that factor? This would be 2x minus 1, x plus 1. Does that check out? So that means my factorization is 2 cosine minus 1 and cosine plus 1. And of course, like every quadratic equation you solve by factoring, you're going to do what next? Set them equal to 0. So we get cosine equals 1/2 and cosine equals -1. Now, it's so tempting to stop here because in a regular equation, this is where you're done. This is it. But we aren't done until what? Until we have figured out the angles. The answer to the question is an angle, kids. This is not an angle. So we got to figure out what angles have a cosine of 1/2. In order to do that, you got to stop and think, first of all, where could that be? Which quadrants could have a cosine of 1/2? 1 and 4. And if the cosine is 1/2, then this is root 3, and I heard somebody say 60. So the reference angle is 60. One answer is 60. Remember, x equals is your answer, and one of them 60. What's the other one? 300. Now you come over and you do exactly the same thing here. -1. I want you to think about that. I want you to think about a triangle where adjacent over hypotenuse is 1/1. Is that possible? No. If the triangle's not possible, then where do you look? On the circle. So somewhere on the circle, there is an angle where cosine is -1, and that happens right here. So the answers to the problem are 60, 300, and 180. Now you're done. Okay? Everybody good? All right, we got a couple minutes left. What kind of problem do we still need to practice? Or maybe you found one on a review sheet somewhere. What do we still need to practice? What kind of problem do you want to practice?
Can we practice something like that, but do it in radians?
Yep. You need to find the equation. There's one on here. How about sine squared minus 2 sine minus 3 equals 0, and the directions say solve it in radians.
Is that a problem on that?
Well, I modified it a little bit.
Okay.
Okay, so here we go. Here it is. This one's actually a little easier than this one because you don't have to make any changes. It's ready to factor right off the bat, right? They're all signs. Everything's ready to go. So how does that factor? So sine minus 3, sine plus 1. Which means sine equals 3, or sine equals -1. Now we're not done. Remember, our answer is going to be an angle. All right, so so sine is 3. Sine is 3. Does that bother you? Can the sine be 3 over 1? No, because the hypotenuse has to be biggest. So that's not going to work. That's going to be an extraneous root. There aren't going to be any solutions that come out of that. Now I got my circle drawn here. A minute ago we did cosine was -1. Now I'm doing sine is -1. Where on the circle does the sine equal -1? 270. So we're thinking 270. I'll even write it down. But remember, I'm supposed to be answering in radians. So let's stop and think about that for a minute. 270, let's see. This much is how much? This is 180, which is pi. And then I'm going in extra half pi. So 270 would be 1.5 pi's or 3 pi over 2. And that would be the only answer to this problem because the other one turned out not to work. Could we have a tangent equal to 3? Could a tangent equal to 3? Yeah. Wouldn't it be okay to have this situation? That situation's okay, right? But not sine and not cosine. All right, what else? One more. We have time for one more problem. What else do we need to talk about or practice? Antonia?
Can we do 3A?
On this review sheet?
Yeah.
Okay, this is a calculator problem. Because the angles, it's another solve, so I'm looking for angles. And the angles I'm looking for are not special, so therefore I need a calculator to do it. So I'm just going to have cosine x equals 0.37 over 2. Where, that's a positive number. Where could the cosine be a positive number? In 1 and 4. So even though I'm using a calculator, I still got to draw a picture of it because my calculator's only going to give me the reference angle. My calculator's going to give me this angle right here. I got to figure out all the rest. So how do I find an angle on my calculator? First of all, make sure you're in degrees because this problem says to be in degrees. So how do I find an angle? Second cosine 0.37 divided by 2. And it's 79.34. Okay? So what are the answers to the question? Well, the one in quadrant 1, yeah, is 79.34. How about the one in quadrant 4? It'll be 280.66. 360 minus 79.34. Now, let's do the same problem in radians. So we're going to change our calculator to radians. We're going to type exactly the same buttons, right? Second cosine 0.37 divided by 2. But this time, instead of getting these 7 nines, I get 1.38. So what would be my answers in radians? 1.38. And then how am I going to find that other one? Not 360 minus if I'm in radians. Same idea, but I'm going to be using 2 pi. So 2 pi minus that, and it's 4.90. That would be the radian thing. So the only difference when we're doing this on our calculator, we'll make sure you're in the right mode. But then, instead of doing 180 minus, or 360 minus, or 180 plus, you do pi minus, or 2 pi minus, or pi plus, right? That's the only difference. Everything else is exactly the same. Okay, here.
For 3B, if you factor out a tan.
For 3B?
Yeah.
3B? Yes, you would. That's how you would factor.
Okay.
You would factor, so you have tan and tan plus 4. Instead of moving what is equal always solve. Okay, now listen. I am not happy with your lack of memorization. Okay? But I have made a decision that for the test, I am going to give you a formula sheet. Alright? Now, here's the trade-off though, because it's unacceptable that at this point you haven't memorized your formula. But I know what's going to happen on test day. I'm going to have a bazillion 20s. Because if you don't know your formulas, that's where you're at. So I want you to focus on knowing how to do the problem. I'm going to give you the formula sheet. But from now until the end of the year, I reserve the right at any moment in time, once a week, twice a week, once every 4 weeks, to give you a quiz that will count in your grade. All right? So you need to get these learned. But on the test, you will have a formula sheet for both the calculator and the no calculator parts. Are we clear? No whining and complaining. This is
It'll be the week before graduation. She'll pull out that.
The greatest hanging on that B minus.
And then I'm taking the final one.